Alrighty, so this video kicks off our next unit. Unit 5 is on probability. So this first part is just kind of some questions to get you thinking about probability and these games of chance. So this isn't in your blue packet at all. Hopefully you have that or you printed it off. We're going to look at notes on page 4 shortly. But why don't you go ahead and look at the spinner. You can even pause the video. Think about, would you play if the cost of spinning the wheel was $1? If it was 50 cents, would it be worth it? Or if we change the zero space on the spinner to a 0.01. So go ahead and pause the video. Think about those answers. Think about how you might do some calculations to determine your answer. And once you have your answers and you've thought about it a little bit, go ahead and press play again. So what we could do is actually look at the spinner and find the average of these numbers. That it was 0 and 1.25 and 0.99 and 1.75. And if I add up those four numbers to find the average, I'd have to divide by 4. And so that gives us an average of 0.9975. So to help me answer the first question, I would not play this game if spinning the wheel was costing me $1, because the average amount on the spinner is only 0.9975. So that means I'm going to lose $0.0025 on each spin. So then it's not really worth it for me. I know that I'm likely to lose money. Now, thinking of that same average, if I only had to pay 50 cents to play this game, then I would want to play this game. I know that I should be making money, $0.4975 on each spin. That's what's likely going to happen. Now, if I change the zero space on here to 0.01 instead, and then I add up those four numbers again, divide by 4, that changes the average to be $1. And so I don't know if I'd play this game. Meh. The average amount on the spinner is $1, and that's the same as the price to play the game. So really, me as the player doesn't have an advantage, but also the person running the game doesn't have an advantage. It's a nice, fair game. So now, join me on page 4 of your new note packet. The first thing we're going to talk about is expected value. So here's a little think about that situation to help kick us off with Unit 5. If you're like many people, you're probably intrigued by television game shows that provide chances of winning large sums of money. On one popular game show, Deal or No Deal, the contestant chooses one of 26 cases which remains unopened. The 26 suitcases contain all these different amounts of money. The contestant then chooses 6 other suitcases which are opened. At that stage, the player can either keep the suitcase she selected or take the amount of money offered by the bank when the banker calls on the telephone. If she does not take the money offered by the bank, then that player has to open more suitcases and the bank gives a new offer. The amount of each offer depends on which amounts are left in the unopened suitcases. Ultimately, the player either accepts one of the bank's offers or keeps her suitcase. All right, so here's an actual clip from Deal or No Deal. This guy has his case, and so his case either has the $750,000 or the $5 left. He's opened up every other single one of these cases that had the red amount of money in there, And so now he's trying to figure out what to do, accept the deal or hope that he's got the $750,000.
There's only 2 cases left in play. One case is worth $750,000, and one case is only worth $5. Mr. Napa. Hello. Okay. Last offer. $333,000.
Take it!
For the last time in this game, Louis Green. Deal or no deal?
Take it.
You can counter. No counter. Take it.
I'm going to counter.
You're going to counter. Because there's a 50-50 chance that that case is holding $5. If she says no deal, then you are just taking your case. What are you countering at?
This is my counter.
No deal!
You got this, baby. It's okay.
Oh my God.
Louise.
All right. This whole night has been about believing. Louise Green, you're going home with $5. Open your case. There it is there. I am so sorry.
Bummer. All right, so now let's actually consider the math behind the television game. So what's the probability that a player picks a suitcase that contains at least $500,000? So that would be 1, 2, and 3 of those suitcases. So I'll say the probability, I'll use a P for probability. Inside the parentheses is my event, that the suitcase is greater than or equal to 500,000. That would be $500,000. And that was 3 out of the 26 suitcases. So we've answered the first question. Not a great probability if you're trying to win at least $500,000. And then the second part here at the beginning of the game, what is the average amount the player can expect to win if she keeps the suitcases she selected? So what we have to do here is find the average of all 26 suitcases. And so I'd add up all of those 26 values listed above. And get that for my total. Then I'd have to divide it by 26 since we added up 26 suitcases. And so if we went on the show and picked a suitcase, we're expecting that we should win $131,477.54. Now, after several rounds of this game one evening, a player got to the point where there were only 4 suitcases left unopened, including the one that she picked. So the remaining suitcases contained $75,000, $5,000, $500,000, and $750,000. Then the banker called and offered her $212,050 for her suitcase. And we're trying to figure out, is this a fair offer? So this is something we'll talk about more in our upcoming investigations here. But what we want to see is what's the average of these 4 suitcases. So if I add up these 4, Since I'm adding up 4 suitcases, I divide by 4. This really gives me a total of that divided by 4. So the average of those 3 suitcases is $313,768.75. But the bank only offered her $212,000 and some dollars. So, did the banker give her a fair offer? No. The fair offer would have been that average of what was left. So the banker is ripping off this contestant. Now, the contestant refused the offer and opened up 1 additional suitcase. Opening up that suitcase showed the $750,000. So now there's only 3 suitcases left with these 3 amounts. That caused the bank offer to go down. Let's see what the fair offer would have been. So the fair price, again, is when I average these 3 suitcases that are left. And that ends up giving me this amount for my fair offer. So if you were thinking about this strictly based on the math, if this was kind of a pure math standpoint, if you were the contestant, you would say that that's too low of an offer, since it's below the fair, I should say price here, or offer, that was fine. And so you should keep playing until you get a better offer that's closer to the fair offer. But if you're just thinking about this realistically, that might be a lot of money. So you might take it. And that part really depends on you. So there's our little intro to probability, things like expected value, fair price, fair offers, all sorts of fun stuff. So look forward to that coming up more with Unit 5.